Okay, let's try and rock question 7 of exercise 2F from Cambridge. I like this question just because of the way it's worded, and it's not full of numbers. Okay, so we can see there's an A involved, and if we look at part A, we've got find the x-intercept, all right, the x-axis intercept, and it says in terms of A. Now that's nothing to be worried about. It just means that our final answer will have an A in it. So instead of saying the x-intercept is 3, 4, it might be 5A, comma, 0. Why would it be 4? Anyway, here we go. So to find the x-intercept, we know that our y value has to be 0, so we pop that down. And we come to our equation here, wherever the y is, we replace it with x. So it becomes x, sorry, did I just say replace it with x? We replace it with 0. We write x take A, and it's minus 0 divided by anything is 0. So that becomes take 0, which you'll ignore. We go, that equals 4. To get rid of my divide by A, let's times. So we end up with x equals 4A. Done. A ticked off the list. All right. And actually, I'll just come back to A because we've got x equals 4A, and I will write that as a coordinate because we know if we leave it like x equals 4A, that represents a vertical line. So let's just be nice here, be particular. Now with B, find the gradient of the line. So you should be asking yourself, well, how do I find the gradient from an equation? And I hope you straight away say, well, when I get to put it in the form y equals mx plus c, this will be my gradient here. So your job now is to get y by itself for this equation. So I'm going to keep the x take A on the left-hand side. The 4 will come over. Now it's a plus 4 here, so when it comes over, it becomes negative 4. And this take y on 12, to get rid of that, I add y on 12, and it disappears from the left, and we have to add it to the right. So there we go. Now, I don't like the divide by 12 because I want y by itself, so to get rid of it, we times, and I'm timesing the whole side. So it's x on A, take 4 times 12. Now, you don't need to write the brackets there. To be honest with you, I wouldn't have put this line in. I would have gone straight to y equals 12x on A minus 12 times 4 is 48. I'll just take this moment to remind you that this thing here, so 12 over A times x, we can write it like that. We can write it as 12x on A, and we can, I guess, write it like I did there, where it's 12 on A and the x is up, right? That's all. It's all the same thing. As long as you don't put the x downstairs, we're all good. Okay, so therefore, let's get back. What is the gradient? Well, it's going to be the coefficient of x. So we can say, therefore, the gradient is 12 on A. Now, as we're going through these, feel free to pause the video and see that maybe you don't need to listen to the whole thing, that you know what to do. Okay, or feel free to fast forward. So here when we've got find the value of A, if the gradient is 2, once again we've just found the gradient, so we will say 12 on A. We're saying that has to equal minus 2. Again, just rocking your algebra. To get rid of the divide by A, we're going to times, so that becomes minus 2A. To get rid of the times negative 2, we will divide, and so therefore, oh, why did I say negative 2? Positive 2. And therefore A is 6. I think I was projecting with part 2, and so let's not even bother with that now because we know that would be A is negative 6. So you can go ahead and do that. All right, so we'll go onward now to question 8. And this would be the time when you pause the video and you're going to see if you can do this without us or without me. Because if we look at part A, find the x-intercept. Now you know how to do that. We just did that in the first one. So please pause and do it yourself. Hopefully now you are just checking that you did what I'm doing along here. to find your x-intercept, we make y 0. So wherever y is, we're going to replace it with 0. We get 0 equals minus 2x plus c. Remind yourself, what do we want? We want x. So the minus 2x will go on the other side, becomes positive. And to get rid of the times 2, we'll divide. And that's our x-intercept, and we will finish it off nicely by writing it as a coordinate. There we go. A. Done. Okay, we go on to B. Once again, pause, read it, see if you can do it by yourself. Find the value of C if the line passes through the point 1, 7. So another way to say that is that 1, 7 lies on the line. Now, when it lies on the line, basically what we're saying is we've got y equals minus 2x plus c. If this lies on, that's my x, that's my y. What is, even if you didn't know what was going on, what would you be compelled to do? Even if I just said do something, here's a y, you've got y 7. So, yep, you've got it, sub it. So y equals minus 2 times x, and x is 1, so that becomes minus 2 plus c. Pop the minus 2 on the other side, therefore c is 9. All right, done. If we just take a break, I'd hope, again, you would realize this. What we have is we've got y equals minus 2x plus 9. And let's say I had another part to this question. I said, hence, can you find or determine if 10 minus 4 lies on the line? So what would we do? Well, because we haven't got a missing c value or anything, and we've got y by itself, what I would do is sub the x value in here. And what should happen is if this point lies on the line, then when I sub that in and I work out the right-hand side, it should equal y. And you can probably see right now, minus 2 times 10 is minus 20 plus 9. There's no way this is going to be equal to negative 4, which is my y value here. So therefore, we would say that 10 negative 4 does not lie on the line. Okay, so just a different type of way I can word things and how you work it out to see if things lie on the line. Anyway, got our c value, tick. For what values of c is the x-intercept less than or equal to 1? So we go back and we go, well, we just found the x-intercept, it's up here, and we said we want it to be less than or equal to 1. So we will write that in mathematics, less than or equal to 1. Got an inequality here. Now we treat inequalities exactly the same as if it was an equal sign, unless we times or divide by a negative number. Now lucky for us, to get rid of a divide by 2, we just times by 2, which does not involve any negatives here. So what we're saying is C has to be less than or equal to 2. Onward and upward to D. Find the equation for the line perpendicular to at that point. Again, what do we need to find the equation of a line? Slope and a point. In our case, this point is pretty special. It's the y-intercept. So that makes my life a little bit easier. What I can do here is, okay, it's perpendicular to this. So straight away, I can see my slope of that line is minus 2. So I hope we all recall that to get the perpendicular slope, we flip this and reverse the sign. So that's minus 2 over 1. Therefore, the perpendicular slope will be, we flip 1 over 2. This was a negative slope, so this is now positive. So we've got 1 over 2 as the slope. Our point, which is in fact our y-intercept, is 0c. So I can go straight in and put it into the y-intercept form, because that becomes a half x plus c. If you were really pumped on doing the whole cross slope multiplication thing, it would be 1 on 2 equals y take c over x take 0, which is x. 1 times x is x. 2 times y is 2y take 2c. Okay, how are these the same? Well, you can see that if I put the 2c on the other side, I get x plus 2c equals 2y. To divide through by the 2, and why would we do that? To get rid of the times 2. We divide through, we get x on 2. 2c divided by 2 is c. We get y. Now these are the same. Okay, again, a half x is the same as x on 2. Pop that in your little bag of tricks. Alrighty. So hopefully you've just plotted along and you've gone, yeah, I'm not really a fan of having all these c's in there, but I'm able to do it. Okay, let's now, you have got E. I'm just going to erase some of this. Okay, E. Let 0 denote the origin, and let A and B be the x-axis and y-axis intercepts of this line. Okay, part 1, if the midpoint M of the line is 3, 6. I think this is actually a bit of a red herring, because when we see midpoint we sort of go, oh, let's use the midpoint formula, but in order to do that we need a couple of points. We don't have that. All we've got is this equation. If we take it back, what we're saying is if it's a midpoint, we're saying that this line lies on the equation. All right, so what do? We sub. We know our x value, so when we've got 3, 6, what this is saying is when x equals 3, y will equal 6. So I'm going to substitute that into my equation here. So instead of y equals, it's going to be 6 equals minus 2 times x. So minus 2 times 3 is minus 6 plus c. And put the 6 on the other side, minus on the other side, it becomes positive. So therefore c is 12. Okay, if the triangle AOB, find the okay, so basically it's not following on from part 1. This is now a new question, so a new one to find C. Okay, triangle AOB. Again, let's picture this. What's happening is we've got our axes. We've got a line. Now, how do I know it's sloping that way? I know that because it's got a minus 2 there. Now, I just draw it here to keep life nice. That's B, that's A. Oh, actually, no, it's the other way around. Okay, let A be on the x-axis. So that's A, that's B. I don't think it really matters. And our origin is here. The area of this triangle is 4. And by the way, I've just drawn it up here. It could actually, would you agree, could go down here, the line as well. Okay, we're just assuming it's up here. We should be able to tell what the B and the A are. Now we know from looking at our equation, y equals minus 2x plus c. We know our y-intercept is c. So this point here is 0, c. And I also know my x-intercept, we did it up here in part A, that this is c over 2, 0. Again, you've got lots of letters and stuff going on. If I had numbers, this is another tip of how you can work things out when you're stuck sometimes. If I said that was 2 and this was 5, what we're actually saying is this is 5 units wide or long. That's the base. So your base of your triangle is 5 and your height you can see up here is 2. So my base is C on 2 and the height is C. So when we're trying to work out the area of a triangle, we know that area is a half base times height. They tell us that the area is in fact 4. So we've got 4 equals a half. The base is C on 2 and the height is C. Tidying up, times the tops. Remember that's C on 1 there. So timesing fractions, we just times all the tops together. 1 times C. That becomes C squared. 2 times 2 is 4. Here we go with the algebra. Get rid of the divide by 4 times. 16 equals C squared. To get rid of the squared, we're going to square root. And we've got C could be plus or minus 4. Why can it be plus or minus? Because remember, I just assumed and I drew the line there. So that would be, if it was positive 4, that would be positive 4 on 2. So 2, but again, if I had the line actually going down here, then we've got negative 4 as the y-intercept and negative 2 as the x-intercept. Why negative 2? Because negative 4 on 2 is 2, minus 2. Yeah? Okay. Nearly there. If the midpoint M of AB is such that OM equals this. We have to find C. So I think I need a new diagram for that. I'm just going to erase. Okay, so normally I wouldn't erase stuff. I'd keep it all there because normally it flows on. Part 2 relates to part 1 and so on, but these seem to be quite separate. Anyway, here we go. We're drawing our axes again. Now a little tip. If you are sort of tempted to draw your line like that, so it looks almost like an isosceles triangle, try and avoid doing that. So I'm going to exaggerate things here. Okay, that's my A, that's my B. The reason that you don't want to draw it as an isosceles triangle when you're not told that it is sometimes you might end up assuming things that aren't actually true. All right, let's have a look. So midpoint M, so here they're the same, that's M, and we know that that distance is 2 root 5, and then we've got our origin. And again, we know that this point here is C on 2, 0, and we know that this point is 0, C. And you look, we stare, we go, we've got distance to the midpoint. So what could we do? We can't really go from here to here because we don't know that distance. We can't go from, although, yeah, no, we don't know. I guess we could work out the distance with this, but that would be irritating. So what is left? Could we actually work out the midpoint? Because I could then work out the distance from here to here we know is 2 root 5, and this is the origin, 0, 0. It's always nice to find the distance from the origin. Simple. So can I find the midpoint? It's the average of these 2 points. So I hope you agree that our midpoint will be, let's do the y first because I think that's easier, C plus 0 divided by 2. So C on 2. 0 plus C on 2 is C on 2, but we have to divide that by 2. So when we halve a half, we get a quarter, which makes it C over 4. So now we can say the distance from the origin to this is equal to 2 root 5. So that becomes 2 root 5 equals the square root of C on 4 take 0 all squared. So that's just C on 4 squared plus C on 2 take 0, right? You realise the origin is 0, 0. So C on 2 take 0 is C over 2 squared. From your work with the distance formula, we know to get rid of the square root, we're going to square. And 2 root 5, if you want to use your calculator, that's how you'd enter it. By hand, hopefully you're going, well, that's 2 squared is 4, root 5 squared is 5, 4 5s are 20. So I've got 20 equals. Now, when I square a fraction, we square the top and the bottom. So C squared over 16 plus C squared over 4. Not a fan of these fractions. So to get rid of it, normally we times by 16 times 4, but 16 is the biggest factor there. So we can times the whole thing through by 16. Okay, so every term gets times by 16. 20 times 16 is 320. When I times this term by 16, the divide by 16 disappears, so I'm just left with C squared. And when I times this by 16, 4 goes into 16 4 times, so I have 4C squared. Last time I checked, 1C squared plus another 4C squared was 5C squared. We want to get C by itself. Let's divide by the 5. 5 goes into 36 times 64. Oh, look at that. Equals C squared. Therefore, C is plus or minus 8. And again, what's the reason for the 8? Because we drew this line here. Obviously, it could have been down here. And we've got the midpoint going the other way. And there you have it. So hopefully, you're feeling a bit more confident and you're not so concerned about, well, I hope you are concerned about the final answer, but when you read some of these questions, it's, well, what do I have? What do I need? How can I get there? Okay, hope that helps.